Now, the first thing I'd like to say is that this is a very long workshop that's 1.5 hours long originally, but we're going to cut it down to just 20 minutes because ETHGlobal has a fast-paced format. If you'd like to watch the full thing, which I just ran yesterday, check out this QR code. I'll leave it up on the screen for a second. It's a YouTube video which includes a talk about Hedera that is just covering the basics, and it's a non-technical talk, effectively, right? Okay, so thank you. A few more of you have joined us. Thank you. Just scan the QR code. You can watch that YouTube video this later on. And sorry, one more. This is a YouTube video. Scan that as well, and you can watch it later on. And I think I'll start now. Okay, so I'll introduce myself. Hi, I'm Brendan. I am a developer relations engineer at Hedera. And Hedera is a layer 1 blockchain that is EVM compatible, but is also a superset of the EVM because it has a couple of other things, a consensus service and a token service. And the token service is something that we'll talk about today as well. So I'm going to jump straight into the demo. Now, if you have followed the link, right, you should end up at Hedera Hackathon resources as a GitHub repo. I'd encourage you to read everything else, but for now, let's just go to Let's Build, and then open up this link, Hedera Tokens CYOA tutorial. And when you go there, you'll come to this tab, a GitHub README. And this has been set up such that you can be productive and build something on Hedera within 5 minutes or 10 minutes. Basically everything runs in your browser. All you need is a GitHub account. So open this in a new tab, right? And if you've never used Gitpod before, what it is a Docker account with very good developer experience, right? That's the way I like to describe it. So spin up a Docker instance. That's what it's doing now. And then let me just make this a bit bigger. Hang on. Don't want to make it that big. All right. So once you've got here, what you'll see is Visual Studio Code, and it is running inside of your browser. So this is not your desktop Visual Studio Code, but everything is as you might expect in terms of the UI. You've got your files on the left, you've got your file editing area in the middle, and you've got a terminal at the bottom. Now, what the terminal is doing is it's saying, I'm going to help you to initialize the .env file, and in the background, it is also going to install all the dependencies and run them for you. So it makes development very easy. So I'll just show you what the .env file looks like at the moment. It's basically empty, right? And you can fill these in manually if you like, but it's far easier to use this script. So enter a BIP39 seed phrase, hit enter, default, generate a new one. Number of accounts, 3, default as well. RPC endpoint, default. All right, it'll set one up for you. And finally, enter your operator account private key. So operator account is the account that you want to run your scripts using. So just hit enter to use the default, which is the first one that you've generated from your seed phrase. And finally, we have this step over here where it's saying, hey, you need to use a faucet to fund your operator account so that you can begin using transactions. So let's copy that address that starts with 0x, your EVM address, and hold down Command and click the URL, faucet.hedera.com, and that'll open up in a new tab. So if you've used a faucet before, the next few steps will be quite familiar to you. So just paste your address here, press the receive button, then press I'm not a robot, just in case you are, press confirm transaction, and within a couple of seconds you should see HBAR successfully sent, right? That means that the account that you have generated inside of the script is now funded with 100 HBAR, HBAR being the cryptocurrency on Hedera, and you can use that to do transactions, for example, create tokens, deploy your smart contracts, etc. Right? So once you're back here, just click in the terminal one more time, press enter, and then it'll do some stuff in the background. It's basically saying, hey, I'm going to make a few more accounts, and then I'm going to transfer an amount of HBAR from the first account to the other accounts so that they are also funded. So at the end of it, it says, okay, so here is the proposed .env file. Just type Y, enter, and this file updates, right? So, of course, if you're doing this on mainnet, not a good idea to show everyone else, but this is testnet, so it's not a big problem. Okay, so we can close the .env file, and you'll notice over here this little pop-up. What it's just telling you here is that you've run your own instance of an RPC relay. That's your JSON RPC endpoint. It's running here in the background. You don't need to care about it, just FYI, right? Okay, now we're ready. So there are 3 different ways that we can do a token, and I'll try to get through to all 3 of them if possible, but most likely in 20 minutes I can only get to 1 or 2. So here we go, right? So let's start with token HSCS. This is probably the one that most of you are familiar with if you're EVM developers, right? So I'm going to run this script over here. What I'd like to point out is that we're running on Hedera, and I'll make this a little bit smaller, just so it's easier to see. You notice that I am not using any additional libraries to interact with Hedera network that you wouldn't with an EVM network. I'm using VM over here. You can use Ethers.js, Web3.js, whatever you prefer. It'll just work as expected. Now, let's run the script. So cd token HSCS, and then run the script, /script, and autocomplete. Run that. Now, I've set up the scripts such that whenever you see one of these purple lines, what that means is that underneath it, you've got a file URL. You just hold down Command and click on it, and then it'll jump you to the part in the script where that action is about to occur. So it's kind of like a self-tutorial almost. The script teaches you how it uses itself, right? And so what this is doing is it's reading a Solidity file, and it says, okay, I've read the Solidity file. Now this next step is going to fail, right? Because we haven't compiled the Solidity file yet. But let's just see what happens. So you should get an error. Now what we're going to do is run the Solidity compiler. I've set up a script for this. What was it? Compile-smart contract. And then run that. So that runs sol.cjs. I would like to highlight that this is the same Solidity compiler that you would use on Ethereum or any other EVM network. Nothing special about it. So now you'll see that we have an ABI file, right? JSON interface description of your smart contract, and you've got a bin file, which is your EVM bytecode, right? The same set of bytecode that you would use on any other EVM network. Now, let's rerun the script, right? And this time we're expecting it to succeed. So, reading in the Solidity file, reading in the ABI, so that failed previously, now it's running, right? So we've got a bytecode, we've also got our ABI ready in. Now it's checking that our RPC relay, which is over here, is running. So let's just do that. So that was successful. Now we'll submit an EVM transaction. So let's take a look at what's going to happen here, right? So this client is an instance of VM, the EVM library, right? EVM client library. And you're calling deploy contract on it and passing in the ABI and the bytecode, these 2 files. And then you're going to pass in constructor arguments, right, for symbol and name. And then we'll submit the transaction to the network. So let's go ahead and run that. And this transaction will take maybe a couple of seconds, and we're expecting a smart contract to be deployed at the end of it. Now, when the smart contract is deployed, it will only contain the bytecode, and you will be able to see it on a block explorer, right? So this thing over here, this URL, hashscan.io/testnet/contract/address. Let's command click and open that. And we can see over here that we have the smart contract that has been successfully deployed, and you can see it on the Explorer. Now, what you'll see here is smart contract bytecode. Not very useful. It's not human readable. So other developers who want to interact with your smart contract, you know it's a token, but they may not know it's a token unless they know how to reverse engineer EVM bytecode or something, right? But we have a solution to that, right? So we're going to do verification. So Sourceify is integrated with Hedera on Hashcan, and we're just going to call that. And it says, okay, verification status is perfect because it has used this metadata JSON that is the output of the Solidity compiler. Okay, cool. So what we're going to do instead of next step is we're going to refresh this, and we can see the same smart contract again, right? It's the exact same smart contract, but check it out, right? Previously we only had bytecode. Now we also have the source code, so you can see the full Solidity source code of this particular token, the standard ERC20 token. And then you can also have an ABI, and you can even interact with the ABI if you want to via a form, similar to how you do it on EtherScan. All right, so let's go back to Gitpod and go back to the terminal. So what's happening next is we're going to interact with the smart contract, right? So this is an ERC20 smart contract that has been deployed. We're calling write contract via the VM client-side library, saying this is the token smart contract address, and this is an ABI. I'm identifying the function as transfer, and the parameters are the to address and the amount. So I'm transferring 100 units of this particular token via smart contract call. Let's go ahead and do that. Press enter in the terminal. And this will be, also should take a couple of seconds, but it should be slightly faster than deployment. And there we go. All right, so we can see the transaction if we want to in Hashcan. So you can take a look at that. So we can see that there has been a smart contract transaction. And because it's been verified, we can actually see all of the results over here. Let me just make that a bit bigger. You can see the from and to address. You can see the signature, which was the transfer function, and the input and the output. So everything is as expected. Now let's query the token balance. So now we're doing client.read contract. So we're passing in the token address, the token ABI. This time we're calling balance of function. Balance of is a view function, so there's no transaction that needs to be sent to the network. And so this should be much faster. Press enter, and you get 100 units as expected, right? Just note that JavaScript numbers go up to 2 to the power 53. Whereas uint 256 is 2 to the power 56, so therefore we need to use big numbers, hence the end. That's just JavaScript notation. All right, so how long did we take to do all of that, like including the setup all the way through till completing the first task? Anyone want to guess? 6 minutes? All right, I think you got a timer, have you? There you go. It was 9 minutes and 8 seconds, but this particular task took 5 minutes. So yeah, somewhere in between. So what I wanted to do here is that I'm in DevRel, and one of the things that I like to optimize for is a good developer experience. And a good developer experience is a fast one, fast and error-free, so less frustration. So if you can get from nothing, right, all the way through to completing your first task, in this case creating a token, deploying a smart contract in less than 10 minutes, hopefully less than 5 in some cases. So if I don't have explanations, maybe under 5, then to me that's a good developer experience. But I think it's important that you also know exactly how fast you can be productive on Hedera. So I encourage you to try this out on your own. I'll leave the QR code up later on. And let's see, I might have time for the next demo, so I'm going to be a bit cheeky and do 2. And I might get cut off halfway through. So let's see how it goes. So I mentioned earlier on that there's a smart contract way to do a token, which you are familiar with. That was an ERC20 token. There's also a Hedera native way that uses Hedera Token Service, right? So these tokens are intrinsically understood at a protocol level. They don't need to go through a virtual machine execution layer. So no EVM is necessarily involved, right? It just, and it's much faster and much more efficient because there is no intermediary, there's no VM. So what you'll notice here is that instead of using the VM library, I am using Hashgraph SDK, right? So this is the Hedera SDK, and it comes in JavaScript, Java, Go, and a few other languages that you might already be familiar with. So I'm going to open this file now. So cd /token-hts. And this time, because we're short of time, I'm just going to run through it really quickly. I'm not going to do as many explanations. So over here, I'm going to create a new token create transaction, and this is it. This is all the code that you need to create a transaction that deploys a deploys a token. No smart contract involved. Just one JavaScript function with chain methods with the configuration parameters. That's it. I'm not like hiding anything. This is the entirety of token creation, right? Let's press enter. Okay, next one is over here. We're going to sign the transaction, and then we're going to deploy it, send the transaction to the network. All right, and there we go. We have a token, right? No smart contract was involved. There's nothing hiding. It's just all in the SDK. So here we have a fungible token with all the parameters that we've configured, and we have balance in the one account that we have, the operator account. Now we're going to do something called token association. This is just an additional step. You can't just transfer an HTS token to any random address. It has to allow it to be transferred to it. So that's a bit different from ERC20 tokens, which are, they don't require that whitelist. All right, so we'll submit the token transfer. transaction. Okay, so now we've transferred the token as well. And let's check it out, right? So we've got a transfer, and we can see over here, this is transaction fees essentially, and this one's a token transfer. We've transferred 100 units of the token with 2 decimal places. So, from this account to the other account, and the transaction has been successful. Now, let's take a look at how long that took us, right? So the total time that we took for both put together is just under 13 minutes, and this HTS one actually just took us just over 1 minute. That's how fast it is, right? Cool. I think we might actually have how much longer? Sorry? Oh, amazing. Okay, so one more thing that I can demonstrate. I might go 3 for 3. Okay, cd .. token interop. Right, this one has to be really fast. This is more advanced, right? So I'm just going to go ahead and run this script, right? Now you notice here, what I'm going to be doing is interacting with the HTS token, but without using the Hedera SDK. I'm using VM over here. So I'm using EVM tooling to talk to my HTS token to demonstrate interoperability. Sorry, /scripts, and run that. Right, so reminder, you have to do the previous scripts before. Now obtain the EVM address, which we have saved before, load the ABI, check the JSON RPC endpoint, and then now we submit an EVM transaction. So now we're using VM, and I'll show you what this looks like, right? We're using write contract from VM, and somehow we're interacting with a Hedera native service, and it actually works, right? Now let's query the token balance, and previously we had at 100, now it has 200, and it's complete. And let's see, that took us half a minute, right? So really fast. Now, how did that work behind the scenes, right? Let's see. This is a bit advanced. This is Hedera improvement proposal, similar to EIP, and you can actually, it does something called a proxy redirect facade. But what that means is that if you're more comfortable with using EVM developer tools and client-side libraries, you can still use HTS, and it works seamlessly. That's effectively what it means. I think I actually finished everything I wanted to demonstrate today, so amazing. Do we have time for questions? Questions? Yes. What kind of, sorry? Indexer. Okay, so the question was what kind of indexer does Hedera use? So it has something called a mirror node, and the mirror node basically takes every transaction and it indexes it. You can think of it as equivalent to an archival node. What's interesting about Hedera is that it doesn't have the main nodes that execute. They only keep state for a few minutes, and then it discards everything else. So the mirror nodes pick up the entire state and keep it. So the consensus is different from complete state. Yeah. So that's effectively your indexer. Now you can also build third-party indexers on top of that, and some do exist, but maybe we can discuss that after this talk. Do we have another question? All good? Amazing. Thank you very much.